corresponding angles are same, and hence corresponding sides are also same, then and only then we were saying yes, the two given figures are congruent with each other. So if we are having, let's recall, if we are having one of the triangle which looks like this and the other triangle if we are having like this, just a second, and the other triangle is like this, then we can say these two triangles are congruent, but we have to check when we will place the corresponding vertex. Like this is A, B, C, and this is, let's say, P, Q, R. So here, if this two will be congruent, then both the figure will exactly cover each other. Okay, all the sides measurement will be same, all the angles measurement will be same. However, while drawing the figure, I was not that careful. I have not drawn it exactly same. It doesn't looks like that. But if I will say that this side is, let's say, 5 centimeter, this side is 4 centimeter, this side is 6 centimeter, and here again I will say that this side is 6 centimeter, this side is 5 centimeter, and this side is 4 centimeter. And yeah, apart from that, if I will mention that the corresponding angles are also same, corresponding angles are also same, if I will mention that this angle is, let's say, 50 degree, this angle is, let's say, 100 degree, and this angle is 30 degree. If I will mention like that, this is 50, and here again just like the other triangle, then just a moment. Just a second, no? This is 30 and this is 100. If I will mark the angle like this, then we can say these two triangles are congruent. Why? Because corresponding sides are same. What is the meaning of corresponding side? Here we can see clearly that AB and PR, these two are corresponding side. Okay, here we can see that side AC and side QR, these two are corresponding side. Okay, and we can see over here BC and PQ, these two are corresponding, pair of corresponding side. Okay, similarly, if you will mention the angles, you can see angle A is equals to angle R. Angle A and angle R is same. Similarly, angle A from triangle ABC, I'm not writing the proper name A, proper name for this angle A. Proper name will be angle BAC, okay, or angle CAB. I'm just writing angle A from triangle ABC. Angle A is equals to angle R from triangle PQR. But listen to me. This is not we are supposed to write the angle. Okay, we will never ever write the angle like this. Let me write it that way only, so that it will you are also not going to write angles like this. Never we will write angles like this. We will be writing angle like this only. Angle BAC is equals to angle PRQ. Okay, similarly, angle ABC is equals to angle RPQ, and similarly the remaining angle, that is angle ACB, is equals to angle RQP. Okay, this is how we will mention that corresponding sides are same and corresponding angles are same, and hence triangle ABC is congruent to triangle PQR. Triangle AB is congruent to triangle PQR. Now here, if I will ask ABC and PQR are congruent with each other, and if I will ask you, have I written it correctly? Have I written it correctly?
Yes. No, ma'am.
Can you tell me, Harshit, what will be the name of the triangle?
I think it should be RPQ.
It should be RPQ. Let's check
Yes,
it.
ma'am.
Yeah.
A and R, here A and there R, both the angles are same. Here B and there P, both the angles are same. Here C and there Q, both the angles are same. What about sides? Let's check the sides as well. AB and RP. AB and RP, yes. BC and PQ. BC and PQ, yeah. And AC and QR. AC, here AC is equals to QR over there. Can you see it? Why, while drawing the triangle, I have drawn the other triangle. I have drawn the first triangle. I drawn the second triangle. I marked the angle over here. I was marking the angle over there, and then I took a pause. Why? I could have given any angle as a like 100 and other angle as a 3, this 30 degree, and I could have said that this like one of the angle from here is equals to another angle from there. I could have said, but no, you have to be careful. See, name while writing the congruency of triangle, corresponding side and corresponding angle, we have to write it properly. If you understand that, you must have learned this concept in the previous class. Okay, this was all about the congruency, and we understand when we will say two figures are congruent, when we will say, suppose I am drawing a circle and I am drawing a bigger circle, these two are not congruent. These two figures are not congruent because one of the circles radius, maybe let's take the radius, let me take it as a 3 centimeter, and the other circle's radius is 8 centimeters. So obviously these two are not congruent figure. If you will place this one of the circle on the other, you will find that both are not covering each other completely. It is not exactly same. Okay, so same shape we are having, but the size is not same. Okay, that means the measurement is not same. Angle is same. When we are talking about the circle, what can we think about the angle? The complete angle is 360 degree. That only we can think. So angle we cannot say anything. Both are circle only, but radius is not same, so it's not congruent. If I will take a square and then I will take another square, and again I will ask the same question, is this two figure are congruent? Suppose this is square, one of the side is 5 centimeter, this is square, one of the side is again 8 centimeter. Is it congruent figure?
No.
It's not.
No.
Okay, exactly, it's not congruent. Now if I will take a triangle, let's say equilateral triangle, and I'm taking one more equilateral triangle, both are equilateral triangles, so obviously each angle will be 60 degree in each scenario. Angle will be same. Okay, we cannot say that angles are not same. Even if a bigger equilateral triangle is smaller equilateral triangle, angles are same. But since this one's side, that's each side measurement, let's say this is 4 centimeter and let's say this is 9 centimeters, so side are not having same. Okay, exactly same side we are not having. Hence we can say these two figures are not congruent with each other. That's what the meaning of congruency. It has to be exactly same in shape and size. And yeah, we were having 5 rules like side, 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 angle, side, which were helping us to check for the given particular question. Few rules were there. Rather than thinking about all the angles are same or not, all the sides are same or not, which may or may not be given in the question, take like 5 rules are there. You just try to match any rule for the given question according to the data given. Try to match it with any of the rule, and then you can conclude that yeah, both are congruent or not congruent. So this is how you have learned the concept of congruency. Now here we will be talking about the concept of similarity, similar figure. Okay, similarity. So here we will be talking about similar shapes. And in particular, we will be talking about similar triangle. But let's try to understand what is similar shape. So as the name suggests, both the shapes are, if just similar, one is smaller, one is bigger, both are like same shape. Similar means same shape we are having. So can we say these two are similar shapes? Can we say if we are having a small circle and a big circle, can we say these two are similar circle? Is there any other criteria also for the similar shapes? Just like the congruency, which we have to keep in mind. In congruency, we are matching all the sides, all the angles, everything has to be same, exactly same in shape and size. That is the meaning of congruency. What about the similarity? So similarity, there is a certain criteria. Okay, and the criteria I'm going to write it over here. So the first thing which you are going to match when the question is whether two figures are similar or not, two criteria are there. First criteria are all the correct, not all, let me write it properly. Corresponding, again corresponding sides. This criteria, or we can say yes, this criteria particularly we will be using for triangle, but yeah, it is applicable for other shapes also. So it says that corresponding sides has to be in proportion. What is the meaning of proportion? I'm coming to that. And corresponding angles has to be same. So these two criteria are there when we are going to check whether two triangles are similar or not. Congruency and similarity is different. Yes, it's not exactly same. Okay, congruency we understand, similarity we are discussing. After the discussion of similarity, you will be able to say whether the figure are congruent or it is just similar. Okay, so for similarity, the condition is sides has to be in proportion. What is the meaning of proportion? Suppose we are having a rectangle. Okay, we are having a rectangle, and here length of the rectangle I have taken as a 4 centimeter, and breadth of the rectangle I have taken as a, let's say, 2 centimeter. And we are having one more rectangle we are having. And yes, Noah, you are here. Yes, Noah.
Yes, ma'am.
Okay, today we started we just started triangles. So for that only you are here?
I changed my batch.
Or you changed your batch?
Yes, ma'am.
Okay, no worries. So still we have just started the concept of triangles. Okay, so far I was just explaining the concept of congruency of triangle, which you have already learned in the previous class. Okay, and now only we just started with the concept of similar shapes. First we will try to understand what exactly is similar shape, and then we will come to the similar triangle. Okay, so yes, I have given one example here. I have written two criteria for checking whether two shapes are similar or not. So I have the first statement which I have written over here is corresponding side has to be in proportion, and the next criteria is corresponding angles has to be exactly same. Okay, what does it mean? So suppose we have taken one of the rectangle, and that's length and breadth I have mentioned over here. Now another rectangle also I have drawn over here, and I am saying that length of this rectangle is, let's say, 8, and breadth of this rectangle is, let's say, 4 centimeter. Now the question is whether this two rectangle, whether the rectangle ABCD and the rectangle PQRS, these two rectangles are similar or not. So let's get back to the definition. The definition says we can only say two figures are similar when corresponding sides are in proportion. What is the meaning of proportion? Proportion means if you are increasing the length, by 2 times, check it, 4 into 2. then breadth must be increased in the same manner. If that is the case, then only we will say, and yeah, apart from that, there is one more criteria, that corresponding angle has to be same. And I am again and again I am repeating that ABCD is a rectangle and PQRS is a rectangle. So if both are a rectangle, so obviously interior angle has to be 90 degree for both the cases. Yes or no?
Yes, ma'am.
Here also 90 degree.
Ma'am.
So if this is the case, then we can say, yeah, PQRS and ABCD, these two are similar shapes. Okay. And if randomly you have increased the size, like one of the size is increasing by like 2 times, another size increasing 3 times, another size increasing any random way, so we will not say the given figure are similar figures. Okay. So this is the criteria to check whether two shapes are similar or not. Now again, let's get back to our circles. So this is the circle I have drawn at first, and the question we have already discussed that these two figures are not congruent. No, these two are not congruent, because congruency means exactly same measurement, and these two doesn't have. But is it similar? Is it similar? So let's recall the criteria of similarity, and the criteria of similarity says that the sides has to be in proportion, or the measurement of the first shape has to be in proportion with the measurement of the second shape. Here, what is the measurement? So only one measurement we are having for the circle, that is radius. This is also radius. So is it in proportion? Proportion means what? Ratio. A particular ratio must be maintained for all the sides, for all the measurement. Here only one measurement we are having, that is the radius of the circle, and that ratio is 3:8. So for circle, we will say that all the circles, we don't have to check other sides are in proportion or not. If it is not making sense to you, let me give you one example. Suppose I have drawn what can be taken? Let's say I have drawn a quadrilateral. Okay, I have drawn a quadrilateral, and I am drawing one more quadrilateral. This is M N O P, and this is PQRS. MN is, let's say, 7 centimeter. PQ is, let's say, 8 centimeter. NO is, let's say, NO is 14 centimeter. And QR is, let's say, 12 centimeter. OP is, let's say, 21 centimeter. And this is 24 centimeter. MP is, let's say, 35 centimeter. Just a second. Yeah, let's take 35 centimeter, 40 centimeter. Yeah. So we will check. And yeah, I'm saying that the angles, like all the angles, corresponding angles are same over here. This is same as this one. 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 Okay. Corresponding angles are same. Okay. So now we will check. Just a moment. No. Yeah. Now we will check. Okay. The second criteria is getting fulfilled over here. That the second criteria says that corresponding angle has to be exactly same. That means for the first figure, all the angles has to be exactly same with the second figure's angle. Okay. Now the first, yes, anyone saying, and anyone is talking about anything or asking anything?
Ma'am, the first criteria isn't fulfilled over.
Yeah, we will be checking whether the first criteria is getting fulfilled or not. Corresponding sides are in proportion or not. Okay, what is the meaning of proportionality? I am going to show you the meaning of proportionality. Here, if you will find the ratio of Mn to Pr, you will be getting 7/8. Yes or no?
Yes.
Similarly, if we will find the ratio of the other side, that is NO by QR, we will be getting 14/12. And if we will just cancel, reduce it to lowest fraction, it will be 2 7 times 14, 2 6 times 12. So we are getting 7/6. Okay, let's check for the other sides also. If we will be checking for the remaining sides, that is OP over SR, corresponding side are in C 21/24, 3 7 times 21, 3 8 times 24, 7:8. And if we will be taking the remaining side, that is MP over PS, we will be getting 35/40. That means 5 7 times 35, 5 8. So we are getting 3 ratios are exactly same. Okay, corresponding sides ratio when we were finding, we are getting 7:8, 7:8, 7:8, but one of them is not same. Can you see it? And if that is the case, then we can say these two figures are not similar. So understood what is the meaning of proportionality? That side will increase in a certain proportion or will decrease in a certain proportion. That means all the side will maintain same ratio. Side Mn increased and the ratio is 7:8. It has to be same for all the sides. And if that is not the case, then we will say that it's not similar. So only two condition we are having. One of the condition for similarity is corresponding side has to be in proportion and corresponding angle has to be exactly same. Now again, let's get back to our concept. The concept is this circle and this circle, is it similar? Yeah, it's similar. All the circle, any circle you draw, it will be always similar because here radius is there, radius is there, whatever be the radius over here, whatever be the radius over there, we just have to match the ratios are same or not, and here nothing is there to match. Is it making sense to you? Next, if I will draw a square, a smaller, a teeny tiny square I am drawing, a teeny tiny square I am drawing and a bigger square I am drawing, and we will check that whether these two are similar shape or not. So since these two are square, so this interior angle has to be 90 degree for both of them. So second criteria shorted. What about the first criteria? So if this square is having one of the side as a, let's say 2 centimeter, and here we are having 5 centimeter, this is also 2, this is also 2, this is also 2, this is also 5, 5, 5. So can we say the corresponding sides are in proportion over here? Can we?
Yes.
So from now,
Yes.
only we will note it down in our rule book that two squares, whatever be the measurement, will always be similar, not congruent, always be similar. For checking the congruency, we need to check if it is having exactly same measurement or not. But for saying that is it similar or not, we don't need to know. Two square will always be similar. Any two square you draw, any measurement, any square you draw, if you are drawing two square, a bigger square, a teeny tiny square, a medium size square, a
Is it
whatever square.
always just squares and circles?
Yeah, what?
Is it always just squares and circles and nothing else?
Square and circle. And what about equilateral triangle? What about equilateral triangle? Check it whether both the criteria is getting fulfilled or not. Equilateral triangle. Only one measurement is there. All the
Ma'am, only one
lateral, all
criteria
the...
is fulfilled.
Yes, Harshit?
Only one criteria is fulfilled. That is like angles are same, but not the sides. If it is
Exactly. So yeah, circle, square, equilateral triangle, these three shapes will always be similar. Will always be similar. And what about all the congruent figure? What about all congruent shapes? All congruent figure are similar. Can we say? Let's get back to our first example when we were talking about the congruency. All congruent figure are similar. Is it so? Congruency means what? All the angles, corresponding angle has to be exactly same. And side will be, corresponding side will be of exactly same measurement. So can we say all congruent figure are similar because corresponding side are same? So can we say 5:5? The ratio will always be 1:1. Here 4:4, the ratio will be 1:1. 6:6, the ratio will be 1:1. Can we say?
Yes.
So we don't have to think about sides will be in proportion or not. When we are saying two sets are congruent, that means corresponding sides are same. And if one side from here is equals to another side from there, then next side for the first figure is same as, exactly same as the next side of the second figure. So basically we will be getting the sides in proportion, 1:1, 1:1, 1:1. Yes or no? Suppose I have drawn a figure, again a quadrilateral I am drawing, and I am saying that this quadrilateral ABCD, this quadrilateral ABCD is congruent to the quadrilateral PQRS. Okay, these two shapes are exactly same in shape and size. So obviously angles are same. Angles are same. Obviously angles are same. What about the side? So side, corresponding side has to be of same measurement. Side AB is 5 centimeter. Then there also any, like one of the side will be there which will be of 5 centimeter. If side BC is of 8 centimeter, then one of the side over there has to be 8 centimeter. If side CD is of 6 centimeter, then there any one side has to be 6 centimeter. And if side AD is, let's say, 4 centimeter, then there one of the side must be there which is of 4 centimeter. Then only we can say ABCD and PQRS are congruent. Congruent figure, congruent shapes. Okay, and if these two are congruent, can we say these two are similar also? Can we? Aisha,
Yes,
who else
ma'am.
is there?
Yes, ma'am.
Yes, so from here only one more thing noted down, that all congruent figure will always be similar. Always be similar, because definitely you will be getting such scenario where when you will try finding the ratio between the measurement of the side, you will find that the ratios are in proportion. Proportion means AB is to PQ is exactly same as BC is to QR. Okay, AB is to PQ is equals to 5:5. That means 1:1 is exactly same as BC is to QR. Is, and for the other sides also, check it. Have you understood the meaning of similarity?
yes, ma'am.
Is it crystal clear to everyone what exactly is the meaning of similarity? Similarity of triangle, we will come to that, but not now. First thing first, you need to understand what is the
Ma'am,
meaning of similarity. Yeah.
similarity and proportional is the same thing.
Can you repeat, Maha?
Similarity and proportion are the same thing.
No, similarity and proportional is not same thing. Can you recall that previous class or maybe before that you were having the concept of direct proportion and inverse proportion? Proportion basically means ratio. Proportion means ratio. If I am going to bake a cake, what is the proportion? What proportion shall I take for flour, for sugar, for baking soda, for whatever the ingredient? Okay, what will be the proportion for that? That means what ratio shall I maintain over there? Proportion basically means ratio only. Okay, and in direct proportion chapter you must have learned that if distance increases, then time also increases. Like if we have to cover more distance, we will be taking more time. Less distance, we will be taking less time. These two are in direct proportion with each other. Distance and time are in direct proportion. That means directly related to each other, or we can say, yeah, basically we just try to understand that proportion means ratio. Okay, proportion means ratio. And here why we are saying that side should be in proportion. Side has to be in proportion. Same proportion, same word we are not using. Proportion means same proportion. Same word is hidden over here. Okay, corresponding side has to be in proportion with each other. That means all the sides ratio, when you will be finding, it has to be same ratio. Okay, and this proportion word came from here only in mathematics. One more time you have seen the concept of direct proportion and inverse proportion. The example of inverse proportion you must have seen when we are increasing the speed, then we will be taking the less time. When we are decreasing the speed, then we are taking more time. So inverse and then proportion. So basically proportion means, yeah, ratio only. Let me check if I can give any particular example which will make it more clear. Yeah, a particular example for now I'm not getting. If I'll get, I'll come back with that. So basically proportion means ratio, or proportion means we are comparing. We are comparing different quantities, and that's what we call it in proportion with each other. What is the proportion? What is the, yeah, Nua, you are saying anything?
Can you explain inverse proportion?
Inverse proportion. Inverse means what? In mathematics, inverse means reciprocal, right? Right? Basically, inverse, we call it for now, you call it inverse means reciprocal, right? Or just the opposite scenario. Inverse means just the reverse case, just the opposite case. So can we say that when we have to cover a certain distance from A to B we have to go, and the distance is, let's say, 1 kilometer. Okay, if we will we say that speed and time, these two quantities are inversely proportional with each other. Why we say that? Because you try to understand, when we will increase the speed to cover this distance 1 kilometer, suppose one day I just woke up in the morning and I am very lazy, going and taking time I am taking, let's say 30 minutes. Okay, another day I am like feeling very energetic and I ended up taking, let's say, only 10 minutes. So when I have taken 30 minutes, definitely speed was very less. Yes or no?
Yes, ma'am.
And when I covered the same distance in 10 minutes, definitely I was moving fast. Speed was more. Yes or no? So here only the relation, again the inverse proportion case. Proportion means we are comparing the things. Proportion, when we do the comparison in mathematics, we write the ratio between my age to your age. We are doing the comparison between my age to your age. Okay, so here also we will say that sides are in proportion. That means you try to understand that sides are in same proportion. Okay, corresponding side has to be in same proportion. Okay, same word is hidden over here, which we need to understand. Is it making sense to you, Maha?
Yes, ma'am.
Okay, Noah, are you getting it? Why I said that speed and time, these two quantities are inversely related with each other.
Yes, ma'am.
Okay, and time and distance, these two are directly related with each other. One will increase, another will increase, one will decrease, another will decrease. Okay, so yeah, this is the concept of similarity. Anyone having any confusion so far? If you understood, then let's do the first exercise. Few fill in the blanks questions are there. I believe we will be able to do it now. All circles are dash. Which one? Congruent or similar?
Similar.
It's similar. Congruent we cannot say. Congruent we understand. Exactly same in shape and size. All squares are again
Similar, ma'am.
similar. Because we can, for a square there is only one measurement, like all the sides are same, and that will give us that will be the advantage. Okay, we will be able to find the ratio between corresponding side as the same, and since we are saying it's a square, so interior angle will be definitely same. Now all dash triangles are similar.
Equilateral.
Yes, only equilateral are similar, not another triangle. We cannot talk about any other triangle. We cannot say scalene triangle, isosceles triangle. We cannot say. We can only talk about equilateral triangle, and hence all equilateral triangle, whatever you draw, Harshit will draw equilateral triangles, Zanab will draw equilateral triangle, Noah will draw equilateral triangle, Maha will draw equilateral triangle, Aisha will draw an equilateral triangle, and whatever measurement each one has taken, all will be similar with each. Okay. Now the next one is two polygons of the same number of sides
Equal.
similar. Yes, let me write it. If their corresponding angle are dash.
Equal, ma'am.
Yes, it has to be corresponding angle has to be equal, and their corresponding side has to be in
proportional.
Exactly. Corresponding side has to be proportional. This is how we write the language, but we understand. Okay. Corresponding sides are in dash. Here we will be writing proportional. Okay. Proportional means all are maintaining the same ratio. That's what the meaning of proportional. Okay. Any confusion so far? Anyone having any confusion?
No, ma'am.
No.
Okay. Now we will be talking about this theorem. Let's start the discussion. I wanted to give a whole class for this theorem because it's that important. Thales theorem or basic proportionality theorem. It is very important. We will devote a whole class, but let me for now write the statement. If a line is drawn, if a line is drawn parallel to one side of a triangle, and is the other two sides Okay, let's try to understand the statement. Again, we will be taking this statement, and along with the statement theorem, we will prove this theorem, okay, in the next class. So basically, the theorem says that this is the theorem given by Thales, okay, mathematician Thales. Okay, in exam, it can directly come as explain Thales theorem and hence prove it. So the statement which I have written on the screen, you have to write this statement and then you have to prove it also. Or maybe the statement will be given to you and you have to just prove it. Or maybe the name, the another name is also basic proportionality theorem. So the theorem says that if a line is drawn parallel to one side of a triangle, okay, a line is drawn parallel to one side, a triangle you are having, okay, a line is drawn parallel to one side of a triangle. So maybe the line is drawn like this, or maybe we are having triangle like this, and we are drawing the parallel line. I'm drawing with green color. So this is the parallel line, parallel to this side, okay. This is the parallel line. Parallel line can be any way. This is the triangle we are having. And we can also draw parallel line to the third side, this side. Okay. So this triangle ABC, here we have drawn a parallel line parallel to BC. Okay. You can see over here. Again, this is a triangle ABC only. But this time I have drawn a line which is parallel to the side AC. Can you see it? And again, triangle ABC. And here I have drawn a line which is parallel to the side AB. Okay. You can draw any way you can draw. Okay, the theorem says that if a line is drawn parallel to one side of a triangle, so one side means any side's parallel line you can draw in the triangle. Okay, a line we can draw which is parallel to one side of a triangle, and the criteria is the parallel line which you are drawing, the green line which we have drawn now, it must intersect the other two sides. It must intersect the other two sides of a triangle. It must intersect the other two sides of a triangle. See, this is parallel to BC. This is parallel to AC. And this is one more thing. Let me mention it over here. In mathematics, in most of the cases, this arrow represent parallel lines. Okay. Whenever arrow is given, it must be written in the question. In our CBSE curriculum, they just keep it a point, they mention it properly that this line and this line are parallel with each other. But in other curriculum, they don't even mention. They just draw the arrow and they just give the figure and they just ask the question, find this angle, find that angle. And just by looking at the arrow, you have to understand that these two are parallel lines. Okay, so I'm just mentioning it over here. Arrow means these two lines are parallel with each other. Now the theorem says that if a line is drawn parallel to one side of a triangle, intersect the other two sides. You can see the line which we have drawn, parallel line. It is intersecting the other two sides of the triangle. Okay, here this is EF. EF is parallel to BC. We have drawn EF parallel to BC, but that E and F, it is intersecting the other two sides of the triangle at point E and F. Okay, same for the other. If this is the case, okay, then the other two sides are this parallel I have written. Let me wipe it for now. Then the other two sides are divided in the same ratio. That means here we can write